morning, Year 10s. I just wanted to, Professor Bones is going to be my assistant today. Thank you very much. He's going to make sure that I don't make any bloopers, which I might. Now remember that if an ion loses electrons, so for example, if we look at fluorine, okay, fluorine's electronegativity is 2,7. Now we know that atoms want to have a full outer shell. That's what they want to become happy. They need a full outer shell. So that means for fluorine it means 8, right? Because it's in the second shell. So it actually wants 8 electrons. Remember that electrons are negative. So if we're going to add an electron into here, and they don't just appear out of nowhere, another element would have had to have donated that electron. It will then end up with the electronic configuration of 2,8. However, it's not fluorine now, okay? Because fluorine, 2,7, that's an atom and it's neutral. Whereas once we either lose or gain electrons, we're gaining a charge. In this case, we gained an electron, so we've gained 1 negative charge. Now, we don't write the letter 1, okay? Because just having the charge there shows us that it's 1 negative. So it would actually be written as fluorine negative 2,8. Okay, and now it's not actually fluorine, it's fluoride. Alright, so remember the non-metals, the second part of their name, the last part of their name will change from INE to IDE, and we end up with fluoride. Alright, let's have a look at another one. We'll look at magnesium. Now magnesium has an atomic number of 12, okay, so that means there's going to be 2 electrons in the first shell, 8 electrons in the second shell, 2 electrons in the third shell. That means our electronic configuration for magnesium is 288. Remember, all atoms want is a full outer shell electron. They're either going to lose or gain electrons or share electrons. At the moment, we're just looking at losing and gaining electrons. It was much easier for fluorine. It had 7 in there already. It's going to be much easier for fluorine to grab an electron, to accept an electron, than to try and donate its 7. In this case, though, with the magnesium, it's got 2 electrons in the third shell. It's going to be easier for magnesium to donate those 2 electrons than to try and accept 6 off another element. So what's going to happen here is that magnesium will donate 2 electrons. All right, these 2. It's then going to form, now because it's a metal, its name stays the same when it's an ion. So it's still going to be magnesium, but it's going to be Mg. Now we lost 2 electrons, so now it's going to be positively charged. Because we lost 2, it's going to be 2 plus. So that's the charge on a magnesium. So I've just shown you a cation and an anion. I might go a little bit further with magnesium. Just for those students that are struggling, I want to show you the atom, okay, the atomic structure. I'm going to move Professor Bones out of the way. That's the nucleus. I'm not going to draw it all in there. Oh, actually, what I'll do is I'll just write 12 plus. So that's the nucleus. It's got 12 protons in it, and it's actually got 12 neutrons, yeah, because the mass number is 24. Okay, 2 electrons in the first shell. 8 electrons in the second shell, and we need to get to 12 because its atomic number is 12. We've got 2 electrons in the outer shell, in that third shell. So what's going to happen is magnesium is going to donate these 2 electrons. So it did have 12 negative charges, but seeing it's now donated, the cation of magnesium is now got 10 negative charges. Now, even if you plug that into your calculator and did a maths equation, 12 positive minus 10, that's going to give us 2 positive. So the electrovalency The electrovalency, the charge on the magnesium ion is 2 plus. Now what needs to happen? Something needs to accept those. And you did a couple of questions. I think it might have been chlorine. But I'm going to pick an easier one. So if we look at fluorine, fluorine is going to have 7 positive charges in the middle. First shell 2. Second shell 7. 9. There are 9 protons because its atomic number is 9. Okay, so what's going to happen here is magnesium is going to donate 1 of the electrons over here. Okay, so fluorine's now happy. It's gained a negative charge, so it's fluoride now. However, magnesium still wants to get rid of that 1. What actually happens here, and if you did the questions last week, you would have seen that in the textbook. So 2 electrons in the first shell, 7 in the outer shell gives us 9. Okay, this one's going to then donate to over here. The main reason why I started doing this is to show you how to write an ionic formula, a chemical formula for ionic compounds. The magnesium is 2 plus, the fluoride, there's 2 of them, each one of them gaining an electron. So we've got our Mg. Always put your positive first. Put your metal first, your cation. We have Mg, we've got 1 of them. How many fluorides have we got? 2. I hope you said 2. F, and we have 2 of them. So we subscript it. So Mg, and we have 2 fluorides. I'm going to show you a different way to work it out, because drawing pictures can take a little while, can't it? Mg. I'm going to give you a table this week. It's called an electrovalency table. It actually tells you a lot of the common charges. So you can use this table, and if we look up magnesium, Mg, 2 plus, alright? So it's got a 2 positive charge on it. 2 plus, and then our fluorine, we can have a look at our fluorine, and it's got 1 negative, which will be our fluoride. So our magnesium wants to give away 2 electrons, our fluoride wants to gain 1. I'm going to turn this into a mass equation for you. 2 plus, 1 negative. Think of a seesaw. At the moment, it is not balanced. Okay, or if you want to think about it as a mass equation, 2 plus and 1 minus does not give us 0. We need to get it to neutral. 2 positive, 1 negative. If I add another fluoride, because it's not like you've just got 1 atom of each, you know, in a beaker. You're going to have hundreds, thousands. Let's have a look. 2 plus, 1, 2. 2 negative. 2 positives, 2 negatives. Neutral. It's going to equal 0. Okay, cool. That's balanced. MgF2. That's my ionic compound. That is magnesium fluoride. Right, well, I'm going to go at another one. Okay, this time let's say we're going to use sodium iodide. Now, if you've got your electrovalency table there, you can grab it and you can have a look and tell me what the charges are before I write them on the board. Sodium, it's actually 11, so it's going to be 2, 8, 1. So it's going to want to lose an electron. That's another way to think about it. Or you can just look on the table. And iodide's a bit bigger. So just look on your table. It's going to be I negative. Hey, look at that. 1 positive, 1 negative. Are they already balanced? Yeah. So we have sodium iodide. now is I'm going to show you an example using the polyatomic ions. So the polyatomic ions, sulfate is an example. It's got two elements in it, two different elements. So it's polyatomic, two different atoms. It's got one sulfur and 4 oxygens. Together they make sulfate, or the sulfate ion. Now the sulfate ion has a 2 negative charge on it. Don't expect you to be able to remember those or to work them out. They just come straight off this table. Why don't we combine sulfate, which is a polyatomic ion, with potassium. So we'll look at potassium sulfate. Potassium's in group 1, same as sodium, so it's going to have the same charge on it. And we know our sulfate. Balanced? 1 plus? 2 negative? Not balanced. What do I have to do to balance it? Hopefully you said, add another potassium ion. Let's have a look. 2 plus, 2 negative, balanced? Yes. So, we have 2 potassiums, 1 sulfate. There's the chemical formula. Show you another one. Let's go calcium phosphate. Try and find the ions on that sheet before I get to it. Okay, calcium is 2 plus. It's in group 2 anyway, so that'll give you a bit of a hint that it's 2 plus. Now, our phosphate, it's a polyatomic ion. It's got phosphorus in it and oxygen. You will find that in your table, on your electrochemical table, and it actually has an electrovalency of 3 negative. In other words, it's gaining 3 electrons. They're definitely not balanced. I've got 2 positive, 3 negative. Think about it. I've got to get them to the same. I've got to have the same number of positive to the same number of negative. If I add another calcium ion, I get to 4 plus. I've got 3 negative over here. So then if I go to add another phosphate, I've got 6 negative and I've got 4 positive. Aha! Add 1 more calcium. Let's have a look. 2, 4, 6. I've got 6 positive charges. 3, 6. I've got 6 negative charges. Balanced. Okay, now with this, 3 calciums, 2 phosphates. That is not correct. That is not how I would write the chemical formula. Because what this chemical formula is telling me, I've got 3 calcium ions, I have 1 phosphorus ion, or phosphide, and I've got 42 oxygens, or oxides. I don't have 42. I've got 8. What you need to do when you're using polyatomic ions, a lot of the time you'll need to use a bracket. What that now tells me, I've got 3 calciums, I have 2 lots of the phosphate ion. And if I wanted to count up the atoms, I've got 2 phosphorus and I've got 8 oxygens. Thank you. Hopefully that helped to clarify a few of the concepts from last week. Well done, guys.